Hey everybody, I got a homework assignment here for you. What I'm going to do is put some problems on the screen. I'll introduce them, maybe talk a little bit about them. And then at that point, you can hit pause, try to work them out on your own. Or if you don't think you're ready, you can just go ahead and follow along with me and then do them with me. Once you have your answers already developed and your graph's done, go ahead and hit unpause and then you can watch me work through them. So you can have like a chance to work on your own and then a chance to check them as you go on. So here we go on the first one. All right, so I'm going to graph the original f of x equals square root of x, and then I'm going to allow you some time to do that first problem down there right below it. So the way that I'm going to do this is I'm going to make a t-table, and I'm going to pick points and I'm going to plug them in. And I'm going to plug in points that are easy to evaluate when I do plug in. So I'm going to go with 0, 1, 4, and 9 as those 4 points. And the reason why I chose them is because when I plug a 0 in for x, the square root of 0 is 0, and then I can plot that point. It lands at a nice whole number on the grid. When I plug in a 1, square root of 1 is 1. So I go over 1, up 1, x comma y, x first, y second. I plug in a 4. The reason I chose 4 is because 4 is a perfect square, and it is very easy to take the square root of 4. Square root of 4 is 2. So over 4, up 2. And then the last point that I went with was 9, because 9 is a perfect square. It's a whole number when I take the square root of it. The square root of 9 is 3. So I'll go over 9, up 3. If I connect those points, I would have the square root of x. This is what is called the parent function. It is the most basic version of square root of x. And what we're trying to do then is manipulate that by moving it around, up, down, left, right, and then even do some reflections. So go ahead, and from what you've already known about square roots, you can graph the square root of x minus 3 minus 5, and you can graph that on this same graph if you want to. That way we can compare and contrast. But let me go ahead and give you a few seconds to do that. So at this point, go ahead and hit pause and try to graph that on your own. You should be able to do that without a t-table, knowing the transformations of what the -3 does and what the -5 does. Okay, at this point, if you've hit unpause or you're watching live, you're going to see me work it out. Again, if you need more time, go ahead and just put yourself back into a pause to work on that if you weren't thinking I was ready for that. So there's 2 transformations. The -3 in the square root. Anything inside the square root after the x is always your left and right movements. And it's always the opposite. What I mean by opposite is a negative actually goes to the right and a positive actually goes left. So that's a -3. This one is actually going to go right 3. I'm going to take those 4 points and move them to the right 3. If a number is on the outside of the square root, a -5, that's your up and down movement. And this is an opposite. A negative does go down like you would think. So then this is going to go down 5. So it's going to go right 3, down 5. I'm just going to take those orange points and move them accordingly. So I'm taking 0, 0. I'm going to go to the right 1, 2, 3. And then we're going to go down 1, 2, 3, 4, 5. And now I just have to repeat that process for the 3 other points. So 0, 0 now lands at 3, -5. Right 3, down 5. Move 1, 1 to the right 1, 2, 3. Down 1, 2, 3, 4, 5. 1, 1 is now at 4, -4. Okay, moving 4, 2. To the right, 1, 2, 3. Down 1, 2, 3, 4, 5. And moving your last point, 9, 3. Okay, when I go to move that one, it's going to land off of my graph. So I have some options here. I can go ahead and extend my XY coordinate plane, or I can just not graph that one, because I really only needed those first 3 points to see the pattern of what the heck was going on. that's kind of up to you. If you don't want to extend your graph, if you're working with graph paper, by the way, it probably would not be an ideal thing to do. I'm going to go ahead and try to eyeball it the best I can. I'm going to say right 1, 2, 3, and then I'm going to go down 1, 2, 3, 4, 5. And I'm just kind of looking at imaginary lines, trying to line those up with what I had before. And then just go ahead and connect your points. And it should be about the same curvature if you can draw this pretty good. So that is the new version. The original parent function is in red, f of x equals the square root of x. And then in purple, I have the graph where it has been shifted to the right 3 and down 5. Anything in the square root is your left and right opposite movements. Anything outside of the square root after, up and down movements. Here's your next question. Oh, I went too far. Let me back up. Okay. I'm not going to make the t-table for the original parent function y equals root x. You can go ahead and do that. And then I want you to graph y equals root x plus 2 plus 3. So go ahead and hit pause. Take as much time as you need to graph that. And unpause when you're ready. Okay, you should be back. And then what I'm going to do is plot the original. I'm going to do this in yellow and hope that it shows up. My original 4 points, 0, 0, 1, 1, 4, 2, because the square root of 4 was 2, 9, 3. And I'm not even going to connect those because I don't really care what that parent function looks like. I care about what this new function looks like. I just have to be aware of the 2 movements. There's a number in the square root after the x. That's your left and right. If that's a plus 2, it's opposite. It's going to go left 2. The number on the outside of the square root after the square root is your up and down movement. That's a 3, that's positive, it's going to go up 3. So I'm going to move those 4 points, left 2, up 3. Let's move the first one, 0, 0, left 1, left 2, up 1, up 2, up 3. 0, 0 moves to negative 2, 3, because it went left 2, up 3. Moving 1, 1 to the left once, to the left twice, up 1, up 2, up 3. Moving 4, 2 from your parent function, up 1, up 2, up 3, left 1, left 2. I went out of order there, but it doesn't matter because it lands me in the same spot. Left up is the same as up left. The last one, left 1, left 2, up 1, up 2, up 3. Connect your points. Starting at the end point is 0, 0 to the right. So your end point is now at negative 2, 3. The domain, and by the way, I didn't mention this on the last one, but if I were to ever ask you, the domain, all the x values are greater than or equal to negative 2 because it starts at an x of negative 2 and then goes to the right. The range is all the y values. The range starts at 3 and then goes up from there. So the y values are greater than or equal to 3. That function is always increasing. Not all square roots are increasing, but this function is always increasing. And it is going to be increasing throughout its domain from negative 2 all the way out to infinity. So if you want to add in any of those properties, you can. You can tell me that it's domain, you can tell me what its range is, you can tell me where it's increasing. And if you want to mention, I said it, I didn't write it down, the endpoint is at negative 2, 3. And you should always see this pattern of this negative 2 and 3 being constantly used somewhere in the increasing domain and range aspects. Okay, question 3. Square root of x minus 4 minus 3. Plot your original 4 points and then move them however the problem says. Go ahead and hit pause. I'll be back in a second or whenever you unpause. Okay, if you've unpaused, you're ready for some answers now. I'm going to plot my originals. 0, 0, 1, 1, square root of 1 is 1, 4, 2, square root of 4 is 2, 9, 3, square root of 9 is 3. I'm not going to connect them, it's not needed. I am interested in what does that negative 4 do? What does the negative 3 do? Inside the radical, to the right of the x, a negative goes to the right 4. Opposite of the sign. 3 on the outside of the radical, after the radical, goes down. Move all those points to the right 4, down 3. Starting at the end point, 0, 0, right 1, 2, right 3, right 4, down 1, down 2, down 3. If you want to write that property down, you can. That's the new endpoint, and it is at 4, negative 3. Right 4, positive 4, down 3, negative 3, x, y. Going back to my graph, 1, 1, move it. Right 1, right 2, right 3, right 4, down 1, down 2, down 3. Move your third point. Right 1, right 2, right 3, right 4, down 1, 2, 3. I'm not going to move my fourth point because it's going to fall too far off my screen. I'm going to connect them though. And it'll look like that. I already labeled the endpoint. If you want, let's do the domain and range. It's not bad practice. The domain is all the x values. The x values start where the endpoint starts and goes to the right. The endpoint has an x of 4. So the x values have to be greater than or equal to the 4 because the graph goes to the right. So the numbers that are bigger than 4. The range is all the y values. The y values are at negative 3. The graph goes up, so it's got to be above negative 3. Y is greater than or equal to negative 3. That function is increasing everywhere. It's increasing throughout its domain. So everywhere to the right of 4. Again, if you're wondering about these brackets versus parentheses, brackets are inclusive, so I'm including 4 in my answer. Parentheses is not including that number, so I'm not including the infinity because I can't get there. Next question. I have a 2 in front of the radical symbol. That is the only number, a 2 in front. So I'm going to give you a second to do that. When you unpause, I'm going to be starting. Plotting my originals. 0, 0, 1, 1, over 4 up 2, square root of 4 is 2, over 9 up 3, square root of 9 is 3. Connect them if you want. Okay, there are no numbers in the radical, so it doesn't go left or right. There are no numbers on the outside of the radical, so they don't go up or down. But what does happen with this one, if you remember, a number in front is responsible for 2 things. If that 2 were negative, it would flip all those points upside down. That number is bigger than 1. Anytime the number is bigger than 1, it is a vertical stretch. So it's a positive 2. It does not flip it upside down, but it does do a vertical stretch of 2. What that means is it's going to lift the heights up twice as high as they normally were, because you're taking the entire equation, which is the y values. So essentially you're multiplying all the y values by 2. Okay, so when I go to multiply 0, 0, I'm not moving it up, down, left, or right. We established that. What I am going to do is stretch it up by 2. So if it has a y value of 0, 0 times 2 is still 0. That endpoint does not move anywhere. But the 1, 1 will move. The y value is currently 1. I'm multiplying those y values by 2. I'm going to be stretching it up twice as far. So instead of it going 1 point above it's now going to go 2 points above the x-axis. It had coordinates 1, 1, and now it's 1, 2. It stretched up twice as high. The point 4, 2, it's only going to stretch it vertically. It's not going to move it left or right. It has a y value of 2. So I'm going to multiply that y value times 2. So instead of going 2 points above the x-axis, 2 times 2 is now 4 points above the x-axis. It stretches up and rises twice as fast. So it is now 4, 4 instead of 4, 2. The last one was at 9, 3. The y value was 3. You're stretching it twice as high. 3 times 2 is 6. So it should go all the way up to 6. Instead of 3 units above the x, it is now 6 units total above the x. And then connect your points. And you can see this function still increases, but it increases much, much faster. Your domain and range from your parent function have not changed. Your domain is still x is greater than or equal to 0. Your range is still y is greater than or equal to 0. The endpoint is still in the same spot because when you multiply 0 times 2, it's still 0. The only thing that gets moved are the 3 other points. So numbers in front are vertical stretches if they are bigger than 1. Here's your next question. 2 root x minus 1. Minus 1's on the outside. You need to know what the 2 does. You need to know what the negative 1 does. We just did one with a 2, so there should be no surprises there. Hit pause. Come back when you're ready. Plotting my originals. 0, 0, 1, 1, 4, 2, 9, 3. Connect them if you want. I'm not going to because I'm only interested in graphing the new problem. Okay, numbers in front. Just talked about this. It's a positive, so it does not flip it upside down. But there is a 2 there as opposed to a 1 being there on the parent function. So there's going to be a vertical stretch of 2. And we also have a minus 1 outside the radical. Numbers outside the radical to the right are your up and downs. Negative is down, so this one's going to go down 1. Now for graphing purposes, you're going to want to do the stretch first, then move it down 1. You always multiply before you subtract with PEMDAS. So let's go to 0, 0. Stretch it twice as high. Currently it's at a height of 0. 0 times 2 is 0. This one does not change vertically, but it does go down 1. 1, 1 needs to get stretched, then move down. Okay, so I'm going to stretch it twice as high. It has a height of 1. It's going to move up twice as high to 2. So the height between the x-axis and the point is 2 units where it used to be 1 unit. But now I have to shift that down 1. So I stretched it up to 2, but now I'm moving it down 1, which actually puts it back where it was originally. The endpoint is not in the same spot. The second point consequently lands in the same spot. The third point, 4, 2. It has a height of 2. Stretch it by 2. 2 times 2 puts a new height at 4. And now move it down 1. So I stretched it to the smaller dot, translated it down 1. That one doesn't land in the same spot. The last point, 9, 3. The height is 3. It's 3 units above the x. Stretch it up twice as high. 2 times 3 lands at 6. But now move it down 1, down 1. So I stretched it 3 additional units to go twice as high, but then slid it down. Connect your points. I'm doing the orange, dark, bigger dots there. So that one got a little confusing. If you were confused on that because of the down one, just kind of rewind that back and then just slowly watch where my pen is moving as I'm talking. I'm going to go ahead and give those properties, even though I haven't been prompting you. I think it's still good to talk about them. Your endpoint, it stretched, but it really didn't, and then it went down to 0, -1. Your domain is all of your x values. They're greater than or equal to 0 because they start at an x value of 0 and go to the right. Your range is all your y values. Your y values started at -1 and then they went up. Notice the endpoint gets used in those two values. This function is always increasing because I didn't do any type of reflections. So it's increasing throughout its domain from 0 to infinity. A couple more questions to go. I got a 1/2 in front of the radical. You need to know what that does. And then I got a +5 inside the radical after the x. Okay, I'm going to graph the original points here. 0, 0, 1, 1, 4, 2, 9, 3. You need to have those 4 points of the parent function memorized. Okay, let's talk about the movements. Numbers in front of radicals are responsible for 2 things: flips, stretches, or shrinks. No negatives on this one. If there's no negatives, there's no flips. There's a 1/2. When that number is bigger than 1, it stretched it. Like if you did ×2, you're doubling something. If you did ×3, you're tripling something. You're making it bigger. This time we're cutting it in half. We're making it smaller. We're doing a vertical shrink of a 1/2. And then also I have to take care of this +5. +5 is in the radical to the right of the x. That's your left and right movements in the opposite direction of that sign. +5, left 5. Okay, you have to do your vertical stretches and shrinks first, then move it left or right. 0, 0. Watch my pen as I'm speaking. Cut it in half, its height. It has a height of 0. 0 cut in half is still 0. So that one doesn't move vertically. But it does go to the left. 1, 2, 3, 4, 5. So its new position, its new endpoint is -5, 0. Let's look at 1, 1. Vertically shrink it by a 1/2. Instead of stretching it, we're shrinking it down. And we're cutting its height in half. It has a height of 1, so go halfway. I'm just going to eyeball. I'm kind of at 1, 1/2. So it's cut in half. Now left 1, left 2, watch my cursor, left 3, left 4, left 5, making sure I'm halfway up. The third point, 4, 2. Vertically shrink it by a 1/2, cut its height in half. Its height is 2. 1/2 of 2 is 1. That's halfway up. Left 1, left 2, left 3, 4, 5. Okay, last one, 9, 3. I'm shrinking that height of 3 in half. 1/2 of 3 is 3/2, or 1.5. 1.5 lands in the middle. I'm going to have to eyeball here because I don't have a half dash. So I cut it halfway. Now I'll go left 1, left 2, left 3, 4, left 5. Connecting those red points. It is still an increasing function, but it doesn't increase as fast as the yellow one did. The yellow one is much steeper because this one got squished down, like someone stepped on it and they squished it down, so they shrank it. It rises, yes, not as fast. It is still increasing, but just not as much. The domain, the x value started at -5 and went to the right, so x has to be greater than or equal to -5. The range, the y values were at 0 and went up. -5, 0, look, -5, 0. Those numbers always come in play. Increases throughout its domain from -5 to infinity. It just doesn't increase as fast as the parent function in yellow that I never connected. There's three things happening here. My y got cut off. You got a +2, you got a -3, and you got a -1. You should be able to figure out what those three movements do. Graph your original, graph your transformations. Go. All right, I'm going to start. If you're not ready, hit pause again. 0, 0. 1, 1, parent function. 4, 2. 9, 3. Connect them, but I don't want my picture to be too busy. Let's talk about the transformations. A 2 in front. That's your stretches and shrinks. Positive, no flip. Bigger than 1, vertical, stretch. You're going to lift it up and it's going to rise faster. A -3. Inside the square root after the x. Right 3. It's always opposite left to right. A number on the outside. Up and down. Down is negative. Down 1. Order of operations says you have to multiply before you add and subtract. So I got to do my stretches. Then I'm going to go right. Then I'm going to go down. Okay, we're going to 0, 0. We've already established when I shrink and stretch 0, 0, it goes nowhere. But now it's going to go to the right 1, to the right 2, to the right 3, down 1. That's your new endpoint. 3, -1. Okay, watch my cursor on this one because I have 3 movements to make. I'm at 1, 1. Vertically stretch it. Raise it up twice as far. Instead of a height of 1, now a height of 2. Right 1, right 2, right 3, down 1. That's your second point. Okay, watch my cursor. Look at the yellow one. Ignore that blue one right below it. That's the second point. Vertical stretch, the green one. It has a height of 2. Stretch it up to 4. Right 1, 2, 3, down 1. Last one. Has a height of 3. Stretch it up to 6. When I go right 3 and down 1, I'm off the screen, so I'm not going to graph that one. Go ahead and connect your points. It's steeper than the yellow one because it is a stretch. Like if I connected this yellow one, look how much faster the green one rises. It overtakes it. Your domain for the green one, the new function, the x values are bigger than 3. Your range, your y values are bigger than -1. This increases faster than the parent function through its domain, 3 to infinity. Last question. I got a negative, I got a 2, I got a +5, I got a 1. There's 4 things that are happening in this one. Hit pause if you're ready to try it on your own. If you're nervous, you can just do it with me. I'm starting right now. Plotting my 0, 0, plotting my 1, 1, plotting my 4, 2, plotting my 9, 3. Graph paper makes this certainly a lot easier. Okay, let's talk about the movements. I got that negative there. That negative is responsible for a flip or a reflection over the x-axis. So that's going to be the reflection part. I'm going to flip it from top to bottom. I got the 2. 2 is bigger than 1. That's a stretch then. This is going to be a vertical stretch. I'm going to stretch it, but I'm going to flip it. I'm going to do the flip before the stretch, by the way. I think it's easier to do the flip first. I got a +5. That's going to be left 5. I got a +1. That's going to be an up 1. Okay, watch my pen closely. I got 4 things to do. I'm going to count them out and say them out at the same time. 0, 0. Flip it, stretch it, left it, up it. That's bad grammar. That's what I'm doing. When I flip it over the X, I can't do that because it's on the X. So when I flip 0, 0 over 0, it stays at 0. When I stretch it, same thing. 0, 0 does not have any change with the negative or the 2. But it will go to left 1, left 2, left 3, left 4, left 5, up 1. That is your new endpoint. -5, 1. The flip and stretch had no bearing on that part, or that point. 1, 1. Okay, watch my cursor as I'm speaking. Don't look up and down. You're going to miss it. You can hit pause and then write it down. First, I'm going to do the reflection. This point where my cursor is 1 point above the x-axis. I'm going to flip it 1 point below the x-axis. Now I'm going to stretch it. Instead of being 1 point below, I'm going to double that. I'm going to multiply it by 2. I'm going to go 2 points below. So let me illustrate. Flip, stretch. Now go left 1, 2, 3, 4, 5, up 1. That's your second point. Point 3, watch my cursor. Try not to make it shaky like I've had 5 Red Bulls today. Flip it first. It's 2 above, 2 below. That's the flip. That's the negative. Stretch it. Instead of 2 below, go twice as far below, go 4 below. Okay, now I'm in the correct spot for the flip and the stretch. Left 1, left 2, left 3, left 4, left 5, up 1. I'll do that one again. Flipped it, 2 below, stretched it twice as far to 4, left, up. Last point. 3, 3, flip it. If it's 3 above, flip it 3 below. Instead of 3 below, stretch it twice as far. Instead of 3 below, 6 below. Flipped, stretch. Left 1, left 2, left 3, left 4, left 5, up 1. Connect your points. This function is going downhill because I flipped it upside down. So the end point didn't do any flipping. All the other points did. So now your domain is still to the right of -5. No problems there. But your range, they were usually greater than a certain value. These are all flipped below. These are going to be less than 1 because they're lower than +1. This function is not increasing. This function is decreasing. It decreases throughout its domain from -5 because it decreases everywhere to infinity. All right, so there's some practice problems. Hopefully those helped out. Hopefully I went slow enough. And for whatever reason, if you were having some issues there, just kind of rewind it. Watch my cursor as I'm speaking. If you look up and down, you're going to miss it moving. So try to watch, pause, then graph. Hope that was helpful. See you guys later.